Alright, hello once again, Jeff Scott of Rankin Technical College. As part of the Rankin Technical College AWD1100 or C# programming class, I've been doing a series of video presentations based on our textbook for the class. That textbook being, as you can see here, Muron's C# 2015. And we have already in class gone over chapters 1 through 11. And the plan then was to go through 12 to 16, skipping 13. So I've done lectures on all those chapters. Now, as you can see, that means there's like about 10 chapters left in the book. There's no way in heck we've got time to go through all those. So let's talk about what we will go through. Right now I'm going to go over Chapter 17, which is an introduction to database programming. Afterwards, I'm going to go over to Chapter 18, which is how to work with data sources and data sets. And then I plan on ending up with Chapter 23, how to use LINQ. Alright, so again, we're going to skip 19 and 20, 21 and 22, and 24 through 26. Alright, so with that said, let's go in and start taking a look at Chapter 17. Chapter 17, as you can see right here, is entitled An Introduction to Database Programming. All right, I think that much of this chapter is more on terminology. All right, I'm going to also show you a few things you can do if you'd like to help learn this stuff. Okay, the stuff that I'm going to recommend rather, they are just that. They're recommendations. So in other words, what I'm going to be showing you is not ideal, it's definitely not the only way to learn this stuff, but I'm going to show you a way, in fact, a few ways that you can learn this stuff. All right? Okay, so let's jump in. All of our objectives, our knowledge objectives. Number 1, learn the hardware components of a typical multi-user system. Number 2, describe the software components of a multi-user database app. Number 3, explain how a table is organized. We're going to go through that in quite a bit of detail. Number 4, explain how tables in a relational database are related. We'll go through that as well. Number 5, describe the use of the following SQL statements. Select, insert, update, and delete. We'll go through them. Number 6, describe the use of these ADO.NET components: a data adapter, a command, a connection, a data reader, a data set, and a data table. So we'll take a look at those. If you hear any noise in the background, I am at work. It is Thursday, March 19th at about 6:45 p.m. and it's just pouring outside. Number 7, compare the structure of a data set with the structure of a relational database. Number 8, describe the terms concurrency, optimistic concurrency control, and last in wins. Finally, number 9, describe 2 ways you can create ADO.NET components. This is my plan. All right? We will go over this chapter. We will go over the next chapter. We will go over the chapter after that. Then we will do some kind of a project as a class. I have not yet checked with my contemporary over at the Rankin St. Louis campus, Mr. Evan Gudmested, but Evan said he was going to try to create some exercises for the database component of the class, and I'll check soon, maybe even after this lecture, to see if he has. All right, so it says here a simple client-server system, and as you know, when you see those clients, those can be anything. Literally now a client can be a phone, it can be a tablet, it can be a laptop, and there's other things it can be as well. The key component though in looking in this system, as far as we're concerned, is the database server that you see on the top. All right, this network, you can say that network is the cloud, you can say that network is the internet. It really and truly in the end does not matter, because as a client, you're coming in here and you're making queries. So you're asking questions of a database. the data for that database and the database itself reside over here. Now, might not just be one database server. Imagine, if you will, the database setup that they must have for something like Google or something like Amazon. They probably have what's called a server farm, where they have several database servers. In fact, they probably have several farms. I can say that with relative certainty. Why? Well, if one server goes down, another one can pick up the slack. If one part of the country goes down, like I mentioned, we're having bad thunderstorm right now. What if they have a server farm in St. Louis, Missouri, and boom, they get a lightning strike and it all goes down? You want to be able to have another server farm somewhere else be able to pick up the slack. Okay, just leave it at that. Three hardware components then are not just the PCs, but again, the PCs, you can do work like this, from a smartphone. You can do work from a laptop or a PC, a desktop, a tablet, etc. All right. The server, again, it's just a computer. It's a computer with more memory and a bigger hard drive. It stores the files and databases that make up the database. When it stores databases, as it says, it's typically referred to as a database server. And the network consists of both the actual cabling and non-cabling parts of the system that allow you to talk directly or indirectly to the database server. All right? In a simple client-server system, the server is typically, as it says, a high-powered PC that communicates with clients over a LAN or local area network. Doesn't have to be that. Could be a much more powerful machine than a PC. Could be that there is no direct connection as you typically have with a LAN. It could be a WAN, a wide area network. All right? And that's what they're saying in the second bullet there. I'm not going to sit and read this stuff to you. Thing on the bottom again, you can also have a wide area network or even a public network like the internet. I'm going to show you some of that stuff as we get going in here. Okay. All right. So the client typically has some software loaded on it. All right. And that software can be used depending on how it is set up. When you think about it, we have not been hooking up to any server in this class. We've been doing everything on our machine, and we will continue to do so. You can load software on your machine so that you are able to use your own machine as, for lack of better words, pretty much the client and the server. Now, if you look at that second bullet right here on the screen, it says each server requires a DBMS or database management server. Database management system. A DBMS, an example of that is Microsoft's SQL Server. Other examples include MySQL, Oracle, etc. There's a lot of them. The processing the DBMS does is typically referred to as backend. Why? Because you don't typically see it. What you would do on the client side, so if you were to take and make queries to a database on the back end, and you wanted those results to show, for example, on a C# form, the C# form would be the front end. The application software, as it says, does the work the user wants to do. All right. That's a pretty bold statement, and it says it can be purchased or developed. It depends on what it is you do want to do. The processing done by the client is typically referred to as front-end processing. Okay? All right. The application software, as mentioned here, communicates with a database management system. It sends queries. All right, queries are questions. When the DBMS receives a query, it provides a service. Typically, what happens is it goes out and requests the associated information from a database server. And then it returns the requested data or the query results to the client. The language that's used to do this is SQL, also called SQL, also called structured query language. It is now pretty doggone close to 50 years old. It was pretty much invented in 1970. It was built off of mathematical types of equations, etc. All right? And I mean, I can give you a little bit of history. It's not that important. The only thing I would say is tell me a lot of other things that have been around in IT for 50 years that are still up and going and are still going strong. I can't think of too many. All right. When you want data to persist, in other words, if you want to keep it between sessions, there's two ways you can do it. You can save things to files, or you can use a database. So as mentioned here, in a file handling system, the processing is done on the client side. None of it's done on the server. So file handling is not a client-server system. Now, this is the database they use in our book. And it, when you look at it, not much different from the stuff we've been talking about. We have been talking about using a product class that contains three elements: a product code, a product description, and a product price. That's what you see in the first three fields here. So each one of these columns represents what's called a field. Each one of these rows represents what's called a record. These records collectively comprise a table. One or more tables comprise a database. So let's write this out. All right. And I'm on 12 minutes, so I can do this. So again, these are my definitions. You're not going to find these someplace in a book or whatever, so don't worry about it. So let's talk about a few terms. A character. Anything, I used to say it's anything you can enter using the keyboard. But you know what? I'm going to put an asterisk there because today, if you're using the Unicode character set, there are relatively 100,000 plus characters you can enter, and there's a lot. That's a lot more than what's on your keyboard. But that's usually the way you think of a character, is what you enter from the keyboard. Those letters, those numbers, those special characters, etc. All right? Then you have a field. And a field is one or more related characters. It can be as small as one character. For instance, if you've got a field that's called first initial, be one character. All right? A record is one or more related fields. Now, usually a record is more than one field, but it's possible, I guess, that you could have one that was only one field. It wouldn't have much information in it, but it would be possible to do that. A table is one or more related records. If I'm going to do a table for the company Jeffrey Paul Scott Inc., and I'm the only employee, then that table will have only one record in it. As I start hiring more people, I'll have more records in it. All right? And what database is one or more related tables. Again, these are my definitions. All right, a couple more, just a couple things I want you to realize. All right, primary key is a unique record identifier. Should be unintelligible. What does all that mean? All right. It's a way to uniquely define each record. So the primary key in each record should be unique. Now, and it also should be unintelligible. What does that mean? That means if someone discovers the primary key, they shouldn't be able to do anything with it. What does that mean? Well, if we take a look here, if someone were to find out the product code for the one on the bottom, Murox Visual Basic 2015, and they found out it was VB15, because product code here, my guess is this is going to be your primary key. So if somebody finds that out, it's not like they can do a whole lot with it, or they'd want to do a whole lot with it. The reason I bring up the fact of this being a field that is unintelligible is in the past, what people would use as a primary key would be a social security number. All right? And that still is how most people are tracked today. The problem is, if someone gets a hold of my social security number, they can do a lot with it. Whereas if I've got a customer number, and let's just say my customer number is my initials, JPS, the number, when I started my account, so it's JPS 03192020, and then some random number afterwards. So JPS 032020 1234. Okay? If somebody finds that, there's probably not a lot they can do with it. Okay? Now, even when you think about it, that's a customer number, that's fine. But a field you don't want, let's say I'm working with MasterCard. Visa doesn't matter, but let's just pick MasterCard. You don't want to really use your MasterCard number as a primary key, because if someone finds that primary key, they can do damage, because they can become you in all essence. If you're going to do that, then at a minimum, what you will want to do is somehow run that through a filter where it's going to convert that number into some gibberish kind of thing. Talk about that, but at another time. All right? Other things. We're going to get into a foreign key. All right? And that is adding the primary key of the parent as a field in the child. What the heck does that mean? Let's pretend for a second that I've got two tables. All right? So let's assume that there's a table about me. And we'll say that I've got an employee number, so an employee ID, an employee first name, an employee last name, an employee address, an employee's city, an employee's state, an employee's zip code, and an employee, let's just say, mobile phone. All right? So that's information. That's very general or generic information that an employer has on me. All right? Let's see, because I'm giving you a bad example, to be honest with you. It'll work, but it's not what I really want to show you, but we'll use it anyway. All right? So let's say that also, for those employees, I also have in another table, right now I have their first name, I have their last name, I have their department, and let's say their department name. I have their salary. Let's just leave it at that. All right. And I want to be able to relate information between these two tables. Okay. Well, one thing I could do is if I've got the first name here and here, I don't need it here and here. So I really could get rid of this field. And I could get rid of this field. Oops. And just copy or bring in and have the employee ID in that field as well. Now I can relate these tables together. What I'm trying to show you here is not what I want to show you. I'm showing you a one-to-one relationship, and I want to show you a one-to-many relationship. Here's the problem that we have in this setup. Let's say that employee ID 10 works for accounting. So somebody types in there accounting, ACCOUNTING, if I spelled it right. Now, later we put in another employee for accounting. And somebody there types in ACCTING. Now we've got two people who work for the same department, but you can't tell because they have different department names. So what I do is I'd come back in here and I'd make a new table. And that table would have a department number, and that table would have a department name. Now I only put the name in there once, and I change this from emp department name. We could make this emp, it doesn't matter. In fact, let's not. Let's leave it like that. So we put this in here as department number. Now look at what we've been able to do. All right. Now if someone comes through, if a person from management comes through and says, all right, I need a listing of everybody's first name, last name, salary, and the department name they work for. I can bring in this information from 3 tables. And I can do it because I'm able to relate these 2 tables because it has this field here and here. I'm able to relate these 2 tables because it's got this field here and here. All right, emp ID is going to end up becoming probably the primary key right here. Emp ID will become the primary key here. And finally, department number will end up being the primary key there. Now that may not make a whole lot of sense. All right. And I didn't do a good job of explaining foreign key, but we'll see it again later. All right. I'm already up to 23.5 minutes. So I'm going to stop right here, pick it up in the next lecture. See you then.